Hello and welcome to my channel. So today, let's look at the daily challenge question 212, the word search 2. So this question is a follow-up of the word search 1. We just did 2 days ago. So the difference is word search 1 only has one word, but word search 2 will have multiple words and then ask us to return all the words appearing on the board. And another difference we might need to consider is we actually need to dedupe the output too, because if a word appear multiple times, it should only appear once in the answer. So because the words is very kind of large, right? There might be the word itself, the length will be less than or equal to 10. But the word itself might have 3 times 10 to the power 4. So to save the space, we would like to use the trie data structure, which we also introduced like yesterday. So we needed to reuse the code of the trie, and then this question also we need to use DFS to search for the existing word. And also we will have some optimization on the trie that we can add to the trie, so that it will make it faster. And the time complexity is it will be O over m times n times 3, like the length, 3 to the power of length, where length is maximum word length. And the space complexity will be O over like the number of the words times times length. K is the number of words, and the length is also the maximum word length. So actually, let's start writing the code. So firstly, the same as before, we need to define this class node, trie node. So we will have because this board only have and the words only have lowercase English letter, so we will have like 26 branches. And also similarly, we have either word. And for this question, we also like to add count, which we will use to remove the word from the trie node. And another thing is we would like to also record the path to the current node. So we will add a string builder property to the trie node. Okay, let's initialize the trie node, which is 26. Next 26 is word is false, count is 0, and string builder is just initialize it. Yeah, also, okay, now similarly we want to have an insert, which is very similar to what we already have. So So we break this to a char array, and we also need to have a root. So we will define a global try node root. So we initialize the root here. So yeah, so now we start doing the we need to also have the node try node initialize with root. So if the node now also need to get the index. Index is the si minus a, which will be an integer between 0 and 25. So if next node next index is null, then we will create a new try node. So then we move node to the node next. Also here we need to add another is a node.count plus plus. So that we are actually counting how many words using this letter. And another thing we want to add is we want to add the string builder. Here we want to we firstly initialize this SB with the previous node SB. Then we need to append the SI. Then we also we will also update the SB with one more letter, so that we have the word also stored in the try node. So you will see later that why we do this. So it makes it easier to get the answer. So also here we need to have a node.isWord as true. Yeah, and also because if we found a word in the board, we actually need to remove that word from the try node. So we want to also implement remove. So remove is pretty similar to the insert, except that we want to count. We don't need this SB anymore, and we also don't need this. So then we actually need to reduce the count, and also we need to set the isWord as false, so that which means the word has been removed from the try, and also we don't need this line. Okay. So yeah, now we have both the insert and remove. So let's firstly construct the try. So we just iterate through all the words and add to the try. And the next step, so now we have already the try, so we can start to we need to also define the global variable m and n. So M is a N is border 0 length. So now we can iterate through the entire board, and then from each location we can start do a DFS. So the DFS, we need to have a board, and we need to have the I and J, and yeah, okay, let's add more if we need it. So also we want to define answer. We want to define an answer list. And another thing we want to add is the direction vector array, so that we can use it to go to the 4 directions. And also we similarly as before, we need to have an in area, so that if it will decide if the coordinate is outer boundary. Yeah, so now we have so we just need to implement the DFS. So let us implement the DFS, and we might need to add more parameter if needed. So so firstly, if the if I is a I think also we might need to add the root. I mean, to add a tri-node to the DFS, so that we can continue searching. So if it's not in the area, of course we will return. Also, if let's get the index. So if the node dot index node dot next index is null, or count node which means we don't have that index in the try, or the node dot next index dot count is 0, which means it's already deleted. So we can also return, which means this route is not feasible. Otherwise, we can change it to to a pound, and we need to change it back later. So yeah, so this is like we recover after searching. So now we just need to go to the 4 directions. Yeah, so we can also using continue the DFS searching. So and also another thing here is if node dot next index is a word is true, then we need to add the word to the answer list, and we need to remove the word from the try. Yeah, and yeah, I think this is basically the code we need, and so in the end, just return the answer. So let's try maybe some examples, see if it's working. Line 55. '66. Cannot find. Oh, right. Oh, yeah. Actually, another thing I think I didn't. There is no word. The word actually is node. Not. I need to get that word. Sorry. So string word is node dot next index dot sb. And then we can create a new string out of that. So yeah, so the string builder, I will use the string builder to now the word should be there, and out of bound, right? Yeah, so we need to add this line to yeah. So we need to like take this part out and create another if, so that the index is already valid. And let's try again. Line 65. All right, so minus 62. Oh, yeah. So actually the board, ij may be, the index might be not valid because it might be a pound. We have like using the pound, right? So when it's pound, then it's not valid. So we need to also add the index smaller than 0 or index larger than or equal to 26, or next node dot next index is null and the count is 0. So yeah, okay, yeah. So now it works, and let's try a second test case. Okay, it seems correct. Okay, yeah. So let's finish this challenge. So so you can see that we had add two property count and string builder SB to the try node, and also we added this remove, which is not we don't have in the this will because after remove word it will the search space is much smaller. So we have less and less words in the try. So which will make it much faster. So you can see that we beat like 98.7% of submissions. So yeah, I will put the code in the GitHub. You're welcome to have a look, and let me know if you have a question. And so if you like the video, please subscribe, and thank you for watching. See you next time.